The crew flight test of Boeing's Starliner spacecraft is coming to an end. Weather permitting, the spacecraft is set to undock from the International Space Station on Friday, September 6th and land at the White Sands Space Harbor, New Mexico just after midnight on Saturday morning. The saga of the first Starliner mission with astronauts on board will end with neither of its two crew members inside when the spacecraft departs the ISS. NASA's Commercial Crew Program Manager Steve Stitch summed it up during an August 24th news conference by calling these past few months a, quote, long summer for the commercial crew team. He says in the end, it really boiled down to the amount of uncertainty that remained surrounding Starliner's Reaction Control System, or RCS, thrusters.
It's challenging to predict their performance. It's challenging to predict the temperatures we'll see. And so that's why it's been tough, and it's taken the time ever since we docked back on June 6th to get to this point.
It certainly has been a busy summer for both Boeing and NASA, and in fact, just getting to the point where they were able to launch the crew flight test has been a journey on its own. Boeing has had to spend an additional $1.6 billion of its own money after its 2019 Orbital Flight Test without crew failed to reach the International Space Station. If you want a more comprehensive look at how Boeing got to this crew flight test, you can click on the Starliner Explained video tag right up here at the top of the screen. But let's take a quick look back at how we got here, what they've been doing throughout the summer and this whole crew flight test process, and then a look ahead at the future of the Starliner program now that the CFT mission is ending without crew on board as it makes its return to Earth. The development of the Boeing Starliner and the SpaceX Crew Dragon were both supported by multi-billion-dollar investments by NASA in 2014. The commercial crew program sought to have two different styles of spacecraft that could offer astronauts rides to and from the ISS. While both companies faced challenges getting to their respective uncrewed demonstrations, they both managed to launch in 2019. But where SpaceX was able to dock with the ISS, Starliner ran into software issues that prevented it from making a docking attempt. Speaking with Spaceflight Now back in March, Leroy Kane, the deputy Starliner program manager, said there was a silver lining. The unsuccessful mission forced them to take a harder, deeper look at the spacecraft before it flew again.
After we got back on the ground safely and we started to look more closely, it led us to ultimately a conclusion that we had not done enough of what we call integrated hardware-software integrated testing in our laboratories. As part of our what we call V&V, verification and validation process, our requirements were to validate and verify a lot of our capabilities by analysis. Much of it by test, but many things all by analysis. And as it turns out, we decided by analysis for some of these things wasn't good enough, and we weren't happy with that anymore. And even though we were meeting our requirements, having done that, we took the extra steps to go add a lot more integrated testing.
In April 2020, Boeing decided to pay for another uncrewed demonstration mission called OFT-2. It would ultimately take more than 2 years to launch that mission, and while it did dock autonomously with the space station, that mission saw some thruster issues during ascent.
Two thrusters failed. The first one had fired. It fired for a second and then it shut down. The flight control system did what it's supposed to, and it turned it over to the second thruster. It fired for about 25 seconds and then it shut down. Again, the flight control system took over, did what it was supposed to, went to a third thruster, and we had a successful orbital insertion.
Over the next 2 years, Boeing and NASA worked together to gain a better handle on the thrusters and deal with a parachute issue that was discovered in 2023. And then on June 5th, 2024,
3, 2, 1, ignition, and liftoff of Starliner and Atlas V.
The Starliner crew flight test took off from Cape Canaveral to begin what was billed as an 8 to 10 day mission.
It was truly amazing, the precision that this spacecraft held. And then we got into day two, the start of day two, it was the same starting off. And then we did have some failures, as we're all aware. We had lost an RCS jet, and then we lost another one. And then you could tell the thrust, the control, the capability was degraded. The handling qualities were not the same. But thankfully, we had practiced and we had gotten certified for manual control. And so we took over manual control for over an hour on the V-bar, the axis where we actually rendezvous with the space station. and for over an hour while the teams on the ground did their troubleshooting.
Those comments from CFT commander and NASA astronaut Butch Wilmore came more than a month after launch during the only on-orbit media event with the crew as of September 6th.
And we're tracking and following along with the teams.
In addition to the jets he mentioned, 3 others went out during rendezvous with the ISS, but 4 out of the 5 total were recovered. There were also some new leaks that cropped up within the service module's helium manifold. Following docking, the helium system was shut off, and subsequent testing was done to check the rate of leaking. It was determined to not be any worse than it had been during the ascent and docking, and eventually, NASA and Boeing felt like they had a good handle on that issue. CFT mission pilot Suni Williams said during the mid-July press briefing that she and Wilmore felt comfortable with Starliner in an emergency scenario.
I feel confident that if we had to, if there was a problem with the International Space Station, we can get in our spacecraft and we can undock, talk to our team, and figure out the best way to come home. Like I said, we've practiced a lot, so I have a feeling, I have a real good feeling in my heart that the spacecraft will bring us home, no problem. But like Butch said, we're learning now to optimize our specific situation and make sure that we know everything about it.
But the sticking point of the summer really became the issue with the thrusters. Throughout these months, NASA and Boeing did extensive testing of the thrusters and their various components, both using the actual thrusters in 2 separate hot-fire tests on orbit and through test campaigns on the ground. The RCS thrusters are needed to help precisely align the Starliner spacecraft as it backs away from the space station and as it prepares to perform its deorbit burn to head back to Earth. Stitch says it was the thruster testing at the White Sands Space Harbor where the conversation really started to shift from being able to bring the crew home on Starliner to looking at a backup option.
I would say the White Sands testing did give us a surprise. We saw in that testing, as we did 5 total simulations with that thruster of a downhill deorbit burn sequence. And so that's when we saw this swelling of the poppet on the oxidizer side. In other words, a piece of Teflon that swells up and it gets in the flow path and causes the oxidizer to not go into the thruster the way it needs to go into. And that's what caused the degradation in thrust. When we saw that, I think that's when things changed a bit for us in that now we know that's prevalent and where is it prevalent in other thrusters and then what could that swelling do in the future. So that's, I think, where we changed course.
Stitch says some of the unplanned manual flying done during rendezvous also caused some additional heating within the dog houses that encase the RCS thrusters, which was another cause for concern.
They've experienced a little more stress, I would say, than the previous flight. Even though the deorbit burn was successful on OFT, the first orbit flight test and the second one, these thrusters have experienced more stress, more heating, and so there's a little bit more concern for how they would perform during the deorbit burn, holding the orientation of the vehicle, and then also the maneuverings required after that. We've also learned in the starboard doghouse in particular, there is extra heating that we have just discovered in the last 2 weeks. And looking at the data a little more closely, anytime an orbital maneuvering thruster fires in that doghouse, there's higher heating.
In contrast to the final decision from NASA, the months of additional testing on Starliner gave Boeing more confidence in its spacecraft. The company published a blog post on August 2nd, which outlined several types of tests and checkouts done since Starliner docked. That included an integrated undocking simulation with the Starliner crew and flight controllers, as well as about 100,000 computer model simulations for scenarios that could be seen during undocking through landing. In an August 7th statement to Spaceflight Now, a Boeing spokesperson said, "CFT is currently a crewed mission, and we still believe in Starliner's capability and its flight rationale. If NASA decides to change the mission, we will take the actions necessary to configure Starliner for an uncrewed return." And as it was, on August 24th, NASA Administrator Bill Nelson opened a press briefing with the news that was difficult for some to hear.
NASA has decided that Butch and Suni will return with Crew 9 next February, and that Starliner will return uncrewed.
That decision carries with it a number of ramifications. Firstly, it means that Wilmore and Williams will remain on the ISS as members of the Expedition 71/72 mission. They've already been spending their time on orbit performing more than 40 science experiments and helping with space station maintenance. Until Crew 9 launches, they will use the Dragon flown on the Crew 8 mission as a lifeboat in the unlikely event that the ISS had to be evacuated. There's already a SpaceX flight suit available for Williams on board the space station, and another suit will be flown up for Wilmore when Crew 9 launches. It also dramatically changes the makeup of that next Crew Dragon flight. Former Crew 9 commander Zena Cardman and mission specialist Stephanie Wilson were both removed from the crew. During an interview with Spaceflight Now back in July, Cardman said she was looking forward to continuing the legacy of the 2017 astronaut class on orbit, a streak that began with the Crew 3 launch back in 2021.
I am deeply humbled, honored, proud to take part in continuous turtle presence in low Earth orbit. I will get to take that baton from Matthew Dominic, who is the commander of Crew 8. I think the real legacy of the turtles is one that we are seeing throughout the office, but it's cultural as much as it is technical. These are people who are incredibly easy to get along with. We really help each other out. We all have different strengths, different weaknesses, and I think they have set an example for me that I'm hoping to carry forward in my mission and then as I get to work with younger classes in the future.
NASA astronaut Nick Hague and Roscosmos cosmonaut Alexander Gorbanov will travel together to the ISS, and that will provide 2 open seats for Wilmore and Williams on the return trip. Following the announcement of the Crew 9 change, Cardman posted on social media saying, "Handing the helm to Nick Hague is both heartbreaking and an honor. Nick and Alex are truly an excellent team, and they will be ready to step up. I only wish Stephanie, Nick, Alex, and I could fly together, but we chose without hesitation to be part of something much larger than ourselves. Ad Astra per Aspera, go Crew 9. Stitch says, making the call to fly Starliner back without crew on board was not a decision that NASA made lightly.
The bottom line relative to bringing Starliner back is there was just too much uncertainty in the prediction of the thrusters. If we had a model, if we had a way to accurately predict what the thrusters would do for the undock and all the way through the deorbit burn and through the separation sequence, I think we would have taken a different course of action. But when we looked at the data and looked at the potential for thruster failures with a crew on board, and then getting into this very tight sequence of finishing the deorbit burn, which puts the vehicle on an entry, and then immediately maneuvering from that into a SEP sequence to separate the service module and crew module, it was just too much risk with the crew.
Nelson says the decision very much lies in the spirit of learning gained from the Challenger and Columbia disasters, where some concerns were not heeded.
There was a culture that did not bring that information up to the decision makers. So NASA ever since has tried very hard to bring about an atmosphere in which people are encouraged to step forward and speak their mind. And I think right today is a good example of that.
As for what happens next with the Starliner program, Nelson also said despite this setback, he was confident Starliner would fly crew again, quote, 100%.
Boeing has worked very hard with NASA to get the necessary data to make this decision. We want to further understand the root causes and understand the design improvements so that the Boeing Starliner will serve as an important part of our assured crew access to the ISS. I have just talked to the new Boeing CEO, Kelly Ortberg. I have expressed this to him. I told him how well Boeing worked with our team to come to this decision. And he expressed to me an intention that they will continue to work the problems once Starliner is back safely, and that we will have our redundancy and our crewed access to the space station.
Those next steps include a planned undocking from the ISS on Friday, September 6th at 6:04 p.m. Eastern Time. The deorbit burn will come around 11:17 p.m. Eastern, with a landing at White Sands just after midnight on September 7th. If weather prohibits that, they will have backup opportunities to undock on the 10th, 14th, and 18th. And finally, once Starliner is back on the ground, NASA and Boeing will have quite a bit of work to do to ensure that Starliner is ready for its full crew rotation mission, Starliner 1. Reporting for Spaceflight Now, I'm Will Robinson Smith.